Hi everyone, and welcome to the first of two videos going through some past exam questions on the topic of electronic structure. So the most common question you get here, and there's not many different types of questions they can really ask about this, is just write out the electron configuration of various different things. Okay. In this case, they're asking us for the electron configuration of zinc. Okay. So we're going to need our periodic table. If we have a look for zinc, here we go, we've got zinc here. The easiest way to work this out is just to count across the periodic table until you get to zinc. So they've given us 1s2 to start us off, so that counts for hydrogen and helium. So if we've got 1s2, next bit we've got is 2s2. Then we have 2p6, 3s2, 3p6, 4s2, and then for zinc we've got all the way across the d orbital, so it's going to be 3d10. Now remember that the 4s does fill up before the 3d. Technically the correct way of writing this is to have the 3d before the 4s, but they will allow you to write it this way around on the exam, and to be honest I would probably write it that way just to remind yourself that the 4s does fill up before the 3d, but it should really have the 3d first. It's then asking us for a bromide ion, so let's just do a bromine atom to start with and then worry about what difference the ion is going to make afterwards. Okay. So again, they've started us off with the 1s2 for the hydrogen and helium. So we've got 2s2, 2p6, 3s2. Where's bromine? So we're down here. So we've got 3p6, 4s2, 3d10, and then this is now 4p, 1, 2, 3, 4, 5, would be a bromine atom. But then the bromide ion is in group 7, so it's going to gain 1 electron. Okay, and so it's going to end up actually being 4p6. Okay, so it has a noble gas electron configuration. Okay, part 3. Here it says the modern periodic table is arranged into blocks of elements based on their electron configuration. Okay, that's what we've been using to work this out, isn't it? We've said this is the S block, groups 1 and 2. We've got the D block in the middle with the transition elements, and we've got the P block over here, and we also have the F block down here, but we don't really tend to do much with those. We now know that electrons are in shells. Shells have subshells, and subshells have orbitals. Okay. Explain what is meant by the term orbital. So this is just a definition. So an orbital is a region within an atom. So it's just a region of space. A region within an atom that can hold up to 2 electrons. Okay, an orbital can always have a maximum of 2 electrons. Okay, and then we could say hold up to 2 electrons with opposite spin. You wouldn't have to write that to get the mark here. It's just a reminder that if you are going to put 2 electrons in the same orbital, they do need to have opposite spin to each other. Then we have a similar question again. What's the electron configuration for an atom of sulfur? So let's go back to the periodic table again and find sulfur is over here. Here we can shortcut this time instead of cutting across. I'll say where is sulfur? So sulfur is in period 3. Okay, so it's going to end up with 3 in its electron configuration. It's in the P block, so it's going to finish off with 3p, and it's 1, 2, 3, 4. So sulfur's electron configuration is going to end up as 3p4, and then we're just going to fill in the gaps. Okay, so after 1s comes 2s, 2p6, 3s2, 3p4. Yeah, let's just check. 1s2, 2s2, 2p6, 3s2, 3p4. Right, then this question we need to be very careful. How many full orbitals are in an atom of sulfur? Now for this, I recommend we're going to draw out our electrons in boxes diagram to work this out. Okay, so I'm just going to put this here and then we'll write the answer over here. So for sulfur, the 1s is just one single orbital, isn't it? And that's full up. 2s is another single orbital. 2p6 is going to be 3 orbitals together, and they're all full up. 3s2 is one single orbital, that's going to be full up. and then 3p is going to be 3 orbitals together. And then if we're going to put electrons into these p orbitals, remember we're going to put electrons into separate orbitals first. We're going to try to avoid pairing them up so that we avoid repulsion. So my 4 orbitals that I'm putting into this p subshell, I'm going to put 1 in each orbital first, and then the 4th one is going to have to pair up. Okay. So how many full orbitals do we have? 1, 2, 3, 4, 5, 6, 7. These 2 orbitals are not full. Okay, they're partly full. Okay, so we've got 7 full orbitals. Last bit here, this is again another one, making sure that we know the difference between orbitals and subshells and shells is essentially what this is testing. So how many electrons, what's the maximum number of electrons that can fit? How many electrons can fit in a 2p orbital? Well, the 2p part is irrelevant. If it says orbital, the maximum number of electrons that can fit is 2. Doesn't matter what type of orbital it is. The 3s subshell, well, this they're trying to catch you out. Okay, the s subshell only has 1 orbital in it. There's always only 1 s orbital. So the 3s subshell might as well say the 3s orbital. So again, that's going to be 2 electrons. How many electrons can fit in the 4th shell? Well, remember the shells follow this 2n squared rule in terms of getting the number of electrons. So if we're the 4th shell, then n is 4, so n squared is 16, so 2n squared is 32, would be the number of electrons that fit in the 4th shell.